for older, wiser heads to share their knowledge with some of us young guns to get better at the job. And as a result, all of us get better together. And that's essentially how I ended up getting into these kinds of user group presentations. My name is Daniel Scheufler. Welcome, y'all, and welcome to Improving. Shall I get started?
Yes, please.
Excellent. So, welcome. The intent for today's talk is borrow the expert's best. These are the 3 design patterns I use practically every day. But, who is this guy who's going zany on the stage? Well, first I'll try and keep that energy a little bit in check. And of course the thing has disconnected. Let's see if we can actually make all of the magic work today. A moment. All right, so I can go this way. And play that from the beginning. There we go. I don't really need my speaker notes anyway. All right. So, hi, my name is Daniel Scheufler. I am a principal consultant here with Improving, and it has been my mission over the last 5 to 10 years of my career to lead software engineering excellently. And yes, I do use the engineering term very specifically. We just write software to no business purpose or no business impact. Why are we doing it? And as a result, I've trended to focus more on people or meta-level programming skills. Not just do this one task well, but what does it take to make the engineering aspect work well? And that's actually one of the things this talk kind of grew out of. I got introduced to software design patterns, gosh, first job out of college, they were joining a book club. I'm like, sure, this sounds like fun. You're gonna buy me a book, let's go. And then I realized that just reading it wasn't good enough. Because, I understood what they said, but, how am I supposed to use this thing? So I, in my infinite brilliance, taught myself Python and the programming practices at the same time. So I could actually have built them, because it was too much of a pain to actually build a working C# project to make it all work. So I solved it in Python, which was awesome. And it taught me more than I really think I could have ever gotten just reading about it in a book. But as a result of that practice, started realizing not only that I need to change a lot of how I was developing, too many things I kept doing, oh, well, I'm just gonna plug it in here. Oh, well, I'm just gonna go and add another one. Why? You're doing the same thing over and over and over again. And over that practice now of 10 years, some patterns have emerged of the ones I always reach for, because they are the most useful tools, and more interestingly, I find they're useful across different language paradigms. So we talked about C#, Java, a couple of other object-oriented programming languages. Those are great now. But when you can start borrowing the paradigms for functional programming, you gain some techniques that really work well for very specific problems that will occur in an object-oriented language, but are a pain to solve with an object-oriented style or approach. These design patterns actually work well in functional, object-oriented, and a little bit in procedural. When you know what you're doing, you can now solve the same problems and borrow approaches from different paradigms and these patterns to solve the problems more easily. But that's what I was hoping to talk about today. The whole point, however, is that this is a presentation for y'all. Like the name for the group, Code4Y'all. So what I would like to start with, instead of talking about what I'm going to go talk about, I want to ask a question. What is it that you came hoping to get? Y'all all saw the meetup. Y'all agreed to come. Thank you for coming. What did you want to get out of it? Matt has got the grin. I'm going to poke him first. Pardon me? No, all right.
My answer is different from everyone else.
Just to see what design practices are common besides solid.
Okay. Common design practices. By the way, I didn't catch your name.
Joshua.
Joshua. Thank you, Joshua. Dave. All right.
Well, I mean, I haven't done this professionally, so I was just curious what actual professionals use and what they. What's the standard practice?
So I'm going to file that as also best practice. Yes, good. Thank you, Ari. Okay. Okay, go to him. There you go. So I'll put a +1 on the best practice, right? What do we do that does well? Okay. What you got for me?
It's kind of in the same vein, but what you consider the top ones, because there's a lot of different factors. Why these specifically?
Why these 3? Solid. I like that. Thank you, Dave. Okay. What else are we in the room? What are we looking to walk away with? What will make this hour and a bit that you're spending out where you could have gone home, play video games, check your stocks, what will make it worth it?
Practical applications.
Practical applications.
When and
Okay.
why.
When and why. When and why. Excellent. Definitely an important thing, especially if we're talking about patterns. Patterns are useless unless you know the situations in which they're useful. Okay? Josh? Gary? Sorry, it's Greg, isn't it?
Or not me, okay.
I'm trying to read your name tag from here and I'm squinting a bit. All right. So I will make.
Different programming languages, how to use it.
Okay. What's it look like in other languages? Okay. Wow. So I'll frame that as what does it look like in a non-OO language? And I'll show some of those.
That's great.
Now, I will give you guys one heads up. Most of the presentation is based upon visual metaphors to help you understand its use and kind of what situations it is most useful in. When we get to the end of the presentation, I'm going to pull out the coding agents and we can kind of walk through a couple of simple examples to show you when does this get used, what does it look like, and especially if you guys have example situations you like, we can see what we can build out as a practical example working from the stuff you're most interested in. Sound good? Excellent. Then, without further ado, here's essentially what you came for. These are the patterns. All right, I like to make certain that you know what you're buying up front. 3 patterns: strategy, the adapter and/or facade, and the decorator. And a small little cue for why or where I found you most needed. Right? The strategy pattern is functional in your object-oriented language because I want to be able to swap functions in, and the only way to do that was to wrap an object around them. The adapter or facade, which is the I reject whatever you said I had to do and I'm going to invent my own. And then lastly, the decorator, which is what if I did that, but also this. So, without too much further belaboring the point, let's talk factory. Right? Pattern number 1. How do I get functional type interchangeability, adjustment? How do I pass a function around like it's an object back in the days before functions were objects? Because back then, at C#, early C++ realistically, the function was attached. It was either a straight method you had to import it, or was attached to a class and therefore associated with that data. How do I make the function dynamically assignable when I have a different need? The most classic example we find for this is like currency calculations. Or if you prefer, taxing strategies. I've got an e-commerce website, and I need to figure out how to do the tax for Great Britain, different than the kind of tax I need to pay in South Texas, different than the tax I need to pay when I'm shipping to Bolivia. Because each of those, I have to pay taxes slightly differently. Oh, by the way, the handling fee in Bolivia is different than it is anywhere else, so it needs its own special logic. How do I handle this plethora of cases without overcomplicating my code base? The solution that we got to was a strategy. I've got some information, my shopping cart, and the place I'm going. And I want to get the tax total, so I can show you the actual amount you're going to spend. Okay, in order to pass around a different one of those for a different country, I'm going to wrap it in a same interface for everybody. It's an object and it's got an invoke method that takes your cart and magically gives you the tax code total. That's all the strategy is. And the reason I showed it in that format is that for anyone who's used to JavaScript, you recognize that as being like a dynamic function declaration. That's what was going on and why we needed this strategy. But why does it still come up useful? Well, what else does the object do that just the regular function doesn't? Well, the function only has the behavior. Object has data. So if I have multiple taxing strategies that are themselves relatively similar, like a country-based taxing strategy, and all that really is different is the rate, and maybe the destination to which the taxes go. Or maybe I have handling, which is always based upon the items in the cart. It doesn't matter where it's going. These patterns can now have data for configuration assigned with them. I can give them a name and pass them around because I can nuop that object. Or heck, I could just load the data from configuration from a database rather than having to put it hard-coded into the code. Hey, good to see you. this strategy is essentially that, right? Solve the problem by making it mutable, right? Now at compile time, I can know all the things my code could do, but at runtime, it can change what it'll do based upon the situation it finds itself in. That is strategy in the whole. Now, I belabored that point. Let's talk a little bit. This is what it looks like, right? So I've got some behavior, some functionality. Given A, I need to get a result B, right? Given the cart contents, I need to get taxes. It's a whole lot like the outlet on your wall. I need electricity. Okay, we all understand more or less how you use that. You plug into it. But I can get electricity from a bunch of different sources. I could get it from the LiPo battery packed there. I could plug it in my house at 240 volts, or maybe you prefer a little bit more of a green solution and get your solar panels out. But all of those provide the same thing: electricity. Different types, all of them having the same signature. Here's electricity out. The strategy is about putting a handle on I need that thing. It's this, that little socket structure. That's what the strategy is. This is my socket. As long as I've got a socket, I can get electricity out. And if I've got that socket, I am promising you that I'm going to get you the 120 volts at so many watts. I promise it'll be exactly what you need. That's what strategies are. Given A, I will give you B. You don't have to care about how it happened. Don't look under the hood. Pay no attention to the man behind the curtain. Here it goes. And so, here's where things get fun. These strategies are just handles on different ways to get that same behavior, to get electricity. And so now, if I have my application where I want to swap in the strategy, say compute the shipping costs for Bolivia, or how much taxes need to go when I'm sending to Azerbaijan, okay, cool. But you just plug it in. And as long as it complies with the strategy, my application can run, no credit, no crazy, just it works. Now, one of the things I wanted to offer was like, okay, so strategy, great. Yeah, I get it. Let me show you some of the tricks. So, for those of you who've used C#, you've used dependency injection before, right? One of the massive pains in the butt you can run into with dependency injection is I've got a whole bunch of rules that I need to get imported into the rules engine, or I have a whole bunch of these pricing strategies, these different tax strategies. How do I load them up quickly? Well, you use the fact that they're all implementing that strategy. They all have that same interface, right? There's the socket. That's how you discover it. So I declare here, hey, here's my I interface. It has the invoke method and takes a type T input and has a type T result. Cool. When I'm actually building the program and declaring my dependency injector, or container I should say, I can literally use reflection in C# to pull out the entire list of objects that comply with that interface from the DLL. Grab that and then do a very basic set of function calls. Hey, app domain, current domain, from the assemblies, all of them, get me all the types. And so now what you end up is essentially a list of type objects, which you can ask the question, hey, are you assignable from that type, the interface, and are you a class? No, this means I'm not getting multiple inheritances of multiple interfaces. Once I have that, I basically say, hey, all of these add to the scope and say they're of that type of interface. So when someone asks for a list of the interface, what do they get? All of the types. All of them. Why is that important? Mostly it's a nice tip and trick to make certain you don't have to go and manually specify them all, especially in cases where you're going to have rules or some other trick where this same interface, different behaviors occurs. Now, any questions on the strategy? We good? So let's move on. Pattern number 2, I reject your reality and substitute my own. I grew up on Mythbusters. They were one of my favorite shows. And I cannot get this quote out of my head every time I think about the adaptable. It's always the, hey, I found this great library, but it's a pain in the butt to set up. Or I found this really awesome function that the other team wrote, but they depend on having an object that I don't have when I make the request. How do I make use of that? But my way, right? I don't have to write the code over again. I just want to kind of make it mine. Well, the adapter lets you do one of two things. Again, we're gonna start with our base function. I've got some stuff and I want something else. Maybe I've got a way to get that, right? The really cool library. I wanna change what I have to give it, right? I don't have everything it's asking for every time I use it, so I'm gonna wrap it in something. And underneath the wrapper, maybe I'll go get it and then we go. But I want that B still out. Or maybe it's like, it does most of the job, but it doesn't get me all the way there. So I'm gonna stick something on the other end so that as I feed it A, I'll do a little bit extra work and then it'll give me the thing I actually want. Adapters are essentially changing the interface to match what I need. Take an existing one, add a couple of layers to it, and change it into what I actually want or need. It's the reject and substitute that I'm talking about. So again, going from our adapter, right? Here's this behavior that I want, but I want it to be somewhat different. The adapter looks like this. We've all seen these when we had to travel, right? Oh, hold on, I need electricity, but I can't interact with the European power supply. So I'm gonna throw an adapter on there and hope the conversion's okay. Or maybe I need a completely different kind of power supply, but like I've still got electricity, so it's okay. I just need to make it a completely different format. That's what adapters do, right? I take my existing something and I bolt something on top of it. This is great when you've got a library that does work you need, but you don't want to have to pass around some like key or some configuration like all the time. You create an adapter that wraps over the main entry point of the library, and for every call you have, it creates the same interface minus this config, so that you just call it simply, but under the hood it's passing the config and your benefits. Or you've got this other thing where like, hey, I've only got C, but like there's a database call to get the thing you want if you've got C. But I don't want it to make the database call every time. Okay, cool, so you add a caching layer. And again, wrap this through. It's called an adapter because just like the thing we plug into the wall to get the thing I actually want, it adapts what I'm given into what I want. You could, however, chain these. Now, I couldn't find like a stack of these things chained out to get me slightly different power variants, but we actually walk around with one of these power bricks all the time, right? Gosh, maybe 5 years ago, laptops started coming out with this thing. You got one end that goes into the wall, and it goes from my regular power voltage plugged into the wall to whatever the heck that thing is. And then that thing goes into the power brick, and that actually rectifies it. It turns it into DC signal, I'm pretty sure. Plus like surge protection, plus a little bit of waveforming to go into that little pin, or nowadays USB-C. But it's like 3 stages. It's all adapters. Power comes in, I change it into whatever this weird thing is. That weird thing goes into the brick, which transforms it into something else, and then that finally comes out to DC power, which powers my laptop. The thing is, when you strap multiple adapters together, what you end up with is a thing called a facade. Facade is how you answer, I don't like that library interface, or I don't like having to make 6 calls to do this one thing. I just want one. You write your own interface on some existing system. That's what you get when you get a facade. E pluribus unum. Out of many comes one thing. So if I wanted to get to D, but I don't want to make 3 function calls all the way through it, well, okay, now up in my app I have a function that exposes A and gives me B. This ends up being useful where you've got a library that does most of what you want, but because of how much work there is, the library tries to be abstract, and it tries to make sure you've got all the options, but in your application, you really only need 3 of them. So why would you give your devs access to all 100 options when they only need 3? Design a facade that restricts that. Hey, don't go use the library directly. Go use this thing. It'll make it easy for you to manage, stand up, and use the thing you actually need. I've done this before several times, usually for like a shape drawing library, where like call A is to instantiate a shape, B is to put it in relative position on the canvas, and then D is the render function for all of that. Like, yeah, no, I don't want my guys managing all of that memory. I'm gonna give them, hand me a list of shapes, I'm gonna hand you the component that renders all of that. Now, so I'm gonna pause on this one because that's tips and tricks, and this is where we start jumping into new paradigms. Do we have any questions so far about adapter and facade? Question? All right. So I promised you guys that one of the things I found that was useful was to take these object-oriented patterns and turn them on their head and find them in functional style. You'll notice that the code here, where the previous example was all in C#, this is in JavaScript. And I've got very functional JavaScript. How many of you have seen map, filter, and reduce? They are my friends. They have an equivalent in C#. It's written in Link. But here, everyone knows what filter's doing. My favorite thing to do is to chain these things to make my job easier. But this is effectively just an adapter pattern. I have this cost expedite function, which takes a list of line items, or given an array of A, and gets me a scalar value. I have a function here that has a single line item that converts. That would be an adapter. Given A, it's B. All right, so I've got this, which takes a array, and then says filter by, is it expedite? So I get an array, and now I've got a smaller array. Smaller array then becomes a completely different type, when I'm mapping it to something else, which is this. And then from array of this extra cost to a single value. A to B, B to C, C to D. And this very eloquently describes everything I want it to do. If I had written this as for loops, yeah, every one of you knew exactly what the pain would be. This is one of the benefits you can get. Now, because I am weird and I like fancy sounding words, I used to call this functional alchemy. Transmuting lead into gold. Lead, a list of random things to the value I wanted, gold, with a bunch of intermediate steps. But it also allows you a unique way to interpret what you're doing. So I'll show you how that would work. I'm going to borrow the whiteboard here. This functional alchemy approach is most useful in the early design phases. So you're thinking about a new feature you need to go to implement. You know you need, so I need some cost to expedite. I'm just using this example, but you would start with what you need. What do I want at the end of this thing? I need to be able to display that cost. Okay, easy enough. What am I starting with today? Well, today I've got line items. That's all I've got. Okay, how do I get to there from here? Obviously, I could try and just iterate through everything. But as y'all already saw in Winsed, you knew that one was going to be painful. But for a given line item, I can easily tell is expedited. And also for a given line item, I can easily tell its individual expedited cost, assuming I know it's expedited. So for an expedited, cost. But notice what I'm doing here. This is a function signature. Given some information, I can get some other information. Given some information, I can get some other information. But this is one line item. So the question becomes, how do I then take this? Well, if I've got a line item array, I could go to a array of expedited using that function. The chain reveals itself as you ask yourself questions of what can I get from what I have? What do I need to get where I want? Kind of bouncing back and forth. If I need this thing, obviously I have to get down to expedited line items so I can sum the costs. If I've got this, I can go here and then 3 chains. You can do the same process with other large groups of data. So this works best for cases like a line item where I need to display a bunch of things on the page, or I have a bunch of records, I need to figure out which ones are the right ones in the database. These larger set operations, functional alchemy is extremely useful for. But it can also be applied to other objects. I used the same approach when I was coaching a group through a migration out of ye olde stored proc into a C# calculation engine for invoices. And the question was, how on earth are we ever going to be able to figure this out? Well, the invoice had these line items. But from the line items, we'd also be able to get rate sheets or other pieces of this. And so function alchemy allowed me to say from invoice to rate sheet, from invoice to line items, from rate sheet plus line item, I can get line item cost. And you can create these mutating signatures and then just draw the chain. How do I need to walk this out before I've written the code to do it? I just know I can. But I'm using this kind of symbolic notation you see here in the comments to reason about it. I found that that's extremely useful when designing systems. To be able to talk with my partner about what is it that I meant to do? How do I get there in sequence of steps? I don't know how that function to get rate sheets works yet. I just know I can. And that, just enough abstraction, allows me to not talk about technical details, but solve the technical problem. Because now if I have a conversation and say, well, you know, the problem with the rate sheets thing is you have to call out to this external API, and each of those calls is massive, which is why we usually batch them. That's scary. So maybe what I need to do then is to grab the rate sheet, a bunch of these at once. And so now I have a conversation about, well, okay, how do I need to make best use of the resources? Instead of it being invoice to rate sheet, now it's invoice sheet, invoice array to rate sheet array. And I can have this conversation back and forth about how I want to balance my design versus the needs that I have of the system versus the approaches I could feasibly take. So adapters is one of my favorite patterns, not so much just because I'm using it every day in code, but because every time I design a system, especially when I'm operating on sets of information, it's the pattern I reach for to abstract the way I'm operating on. Which leaves us with one more pattern, Manchurian candidate. How many of you are familiar with that reference? Okay, got a handful. For those of you who aren't, the Manchurian candidate goes a little like this. You got a guy who was caught in the last Great War, whatever it happens to be. They remake this every several decades for, whatever war. And he comes back as a war hero. He was caught as a POW, he makes it home, yay rah, he starts to run for government. Unbeknownst to the people, Mr. War Hero has been brainwashed. And now on the code word turns into an agent of whatever enemy state we happen to pick, be afraid. The thing is, you can do the same thing in code. Because the serious thing about the Manchurian candidate was he didn't know he was compromised. Whenever he went into this fugue state that he was told to go, do the enemy agent things, he forgot. He never knew about it. Now in programming, that can actually be pretty useful. I've got this good working function, and I don't want to pollute it with another concern. I want to leave it alone. Or I've got this library that I can't actually crack open and change the innards of, but I need to do something extra with it. Pattern number 3, the Manchurian candidate, is how you do that. And it isn't exactly a signature mutation, though it's very close. Because at the end of the day, this thing takes a given A yields B and gives you that back with a little extra. Now, that is a very difficult way to see it. This one's a little better. The way all of this is I start with my do the thing operation. This was the one I actually cared about. But it takes a while, so I want to start a timer to make certain I'm watching it. Oh, and by the way, it's triggered when someone starts typing, like an expensive search operation, as you'd catch again on e-commerce, like I'm trying to search for a product. I don't want to issue another search every single character. That would be really bad for my poor server. So I'm going to debounce it. But my do the thing never knows. Because all it does is get input, issue call. Debounce doesn't care what I'm doing underneath. It's just going to prevent me from firing a bunch of them if I'm inside the time. And of course, my timer is going to time how long it took me to run that search so I can do some analytics on it or something. It's onions, again, layers. From the outside though, I can't tell a difference between do the thing and augmented do the thing. This is the value of decorators. Whether it be timing or logging is one of my favorites, debouncing, any number of these things that, do I want to add debouncing to every one of my API calls? No. I would like to have a debounce function that I know works for anything. that debounces any API calls before I ever issue them. This is a cross-cutting concern. Do I want to add input and output logging and timing to every one of my API calls? No, because, at least not like inside any of the computations, but like the outside stuff, it's all the same every time. Log, I'm calling this function with this stuff, start time. Log, I finished calling this function, here's what I got back, end time. It's the same way every time. Why would I go write that 100 times on my APIs? Or I could just write one function that wraps them all. The decorator is as it's described on the tin. Give me a function, I'll give you a function that does the same thing back, and a little more. This is how, oddly enough, in C#, most of authorization is applied. If you guys look at, and I'm going to draw a little pseudocode here. Right, so if I am in, a controller, and you see something like this, authorize, or this one, those are decorators on public. My handwriting has gone terrible. Result. ...
You should be a doctor.
If only they would pay me. Unfortunately, I don't know the medicine names. Anyway, but those are cross-cutting concerns, right? Authorization, it's the same way every time. HTTP GET, all of the GET endpoints do the same thing. They're decorators. What's fun is there's another name for these. They call it aspects in C#. Aspect-oriented programming, which is essentially to say I want to have this cross-cutting concern that gets applied on everything, and so I'm going to write it once. I made use of this recently. Gosh, this was the cloud refactor. Remember, Matt? To track in an application, big old C# thing, who's actually using this? Because I had an application that had half a dozen product lines that we'd written out, but we weren't certain who was actually using them or how often. So for every one of the landing pages for each of the product lines, anytime you went to go edit one of their deals, I added this attribute, track it. And it would include a name of what page did you just hit, and it would track who hit it and then pull out of the request information the user doing it. So I could log it to my event stream to track. Turns out 9 out of the 12 weren't being used at all. So the project didn't really survive, but at least I knew. This is what a decorator is in my electricity analogy. That is a Christmas light timer. It'll go and spin around, and when it hits one of the green ones, it'll turn it on. Right here. Electrical power comes out here when it's green. And when it hits red, it'll turn it off. Right here, doesn't know anything except that there's electricity flowing. But right here, keeps ticking away until the next green or the next red comes through. More behavior, no change down here. This is, by the way, the effective equivalent of like what debounce is doing for your function. So, as keeping with my pattern, tricks. There are two actually for this one. This is the one I talked to you about getting some information and like a tracking page views on a given C# endpoint. I have some decorator, which is the action filter attribute, that aspect-oriented programming stuff. And I've got some function which is on action execute. This is the method that gets called right before going into the actual invocation. And so I say, hey, by the way, you can actually pull dependencies from your running application off of all things the HTTP context. It has access to your DI container. So I pulled the telemetry service and a couple of other bits. And then I logged, hey, log a page view with this user at this page. Because down here in my controller, on some task I action result of index, hey, decorator with the config value. And that config value, and so now I can tell you what page is this, what business line is it. Anything in your DI container you need to grab use of, it's right there. It's a little tricky to wrap your head around, but extremely useful in circumstances where you need to do the same thing to a lot of different places, but it's always the same pattern. So, by the way, I'm going to pause here real quick. When and why? When and why for the decorator is, I want to do the same thing a bunch of different places. It's the same pattern, but I don't need to change what I was already doing. That's your decorator cue. I need to do the same thing a bunch of places, but not change what was already happening. I need to add to the behavior.
I have a question.
Go for it.
No,
I'll try and go backwards though.
no, that's fine.
Oh, okay.
That's not the code. The decorator that you just talked about, is this something that is only applies to C# or we can use it in other languages?
Use it in all kinds of other languages. Now, the C#, that's the one with the aspect part, like, I think that's specific to C#. But other languages have equivalent things for that. Here's the way you can do it in JavaScript. I also make heavy use of decorators in testing. So, how many of y'all do unit testing? Good, we got a handful. Should be the whole room, but I can be cognizant. Okay, maybe this will get you in on it, right? One of the hardest things to do when you're testing is, did I actually call it? Did it invoke? Or did I just screw up my settings? A spy function is what you want in that case. I want it to do the thing, but I want it to tell me about it. I want to put a little bug or tap to listen in. Well, this is how you do it. Here's the spy on decorator. This is actually the spy function from spyfun.js. Great little library. But I had to reproduce this because I couldn't get it to work with Playwright at one point in time. It's the same basic function though, right? Hey, I'm going to create a spy on some func. What's it going to return? The same thing as some func. But it's going to be an object because in JavaScript, functions are objects. It's going to have the array of the call R's until you tell it to clear. It's going to have the results R's from every time you called it. How many times has it been called? And then the invoke function is going to do a little bit extra. I've been called, catch the args, invoke the function, here are my results, return the results. Same behavior, but there's a little bit of magic you need to do it in JavaScript, right? That args object, right? I don't know what it's calling, but it's going to be the same thing as that. In C# you'd use this with generics. But that function has saved my bacon because I was able to figure out I was actually calling it. I was just failing to restructure the object correctly because I had the results to check against. There are countless other uses you can make of that when you need to spy on your mock, or you need to substitute something in. Again, decorator is used when I need to do the same thing a bunch of times to a bunch of different objects and not change what those are doing. Just need to add to it. Good question. So, that is all patterns. One thing I haven't touched on is the when and why use, because I forgot to do it. Thank you for asking the question though. When and why should I be using strategy? Strategy is I have a bunch of different ways I need to handle the same business need. As I mentioned, like tax computations is the quintessential version of this. I need to compute taxes for that country, and for this country, and for this country. And I want to separate that because I'm always doing tax computation, but the main algorithm only needs to know, do the tax computation. It doesn't even know how to do it for the 12 dozen countries I'm doing it. This can be used in a variety of other ways though. Because remember, the core thing of a strategy is it is an object wrapped around a function. So if you've got rules or validators, strategies are a good option. One of my favorite examples of these was in link query composition. So in Entity Framework, you can create a query. So it's like an iQueryable object, right? You're gonna say, hey, do this and then dot filter by some piece from the object. Well, when you have an application with absolutely massive entities, say for example my invoice example. Hey, I want to filter for invoices that have such and such a rate sheet. Oh, and they should be for this contact who happens to be for this client. Oh, and by the way, I only need the ones that are for this date to this date range. I could manually write all of that. Or I can create a factory to create the strategy for filter by chunks of information. Here's a date range filter. What's it do? It knows how to translate start to end date on an invoice. It's a strategy. What's more is that I've got multiple objects in the database that have date range properties, as long as I've got them named all the same. Reflection allows me to simply state it's an object that has these two things. And now I can make the filter generic. I have one implementation for invoice and another implementation for something else. But this composition allows me to literally say iQueryable comes in, iQueryable comes out. What's different? Well, I added some extra things to it. Which allows for testing, separation of concerns, and gradual strangler pattern on ineffective search queries. One of the things we learned for that was that you really don't want to do text-based search on the largest list. Yeah, things we should have figured out before we did it. I will announce I came late to this project, so I couldn't save them from that one, but we did fix it, because we would do a drastically trimmed down query with this filtering thing, but only return the IDs. And then from the IDs, grab information, and then do a text filter. Because now we went from the entire database to like 100 things. Yeah, it's easy enough to do in memory. But we use the strategy pattern to attach filter functions, or order by functions, or group by functions for this rather complex set of data queries. Now, that strategy, the last one was the adapter. The adapter is I don't like doing it that way, I want to do it my way. That's my adapter reach. But as I also mentioned the other time, I reach for the adapters as an abstraction on what I am actually doing. As long as I can think of it in a function signature like I was doing for the design there, that's my go-to for adapters. I'm going to consider it as a sequence of functions that gradually mutate my information. So that's the hows and whys there. Why these three? I use them all the time. Anytime I'm doing design work, trying to think about it, I'm grabbing an adapter. Anytime I'm noticing, and this happens all the time in React, hey, I've got a form. I'm rendering a form field. All the form fields have a label, the little required asterisk, maybe the help text of like, hey, your validation is wrong. Show me your red text error message. And then they have some kind of an input. That input, factory. What's it going to yield? Some strategy. It's going to be some function that returns HTML. To an input, a select, a radio button, whatever magic my UX guys come up with now, all of those, same interface, given blah, yield some function that gives me HTML. It's probably one of the reasons why I like React quite so much, because I get it. Strategy. And then of course, the decorator is for when, oh nuts, I have to do this 100 places. So, questions? Any that I didn't get there you want to talk more on? All right. Gotta love it when it works. So with that, I have two more things. Number one, if any one of you would like practice on the strategies and implementations we talked about today, I would encourage you, go check out that link. It'll give you a request like, hey, give me your email, that'll sign you up for my newsletter. I do blog posts on software engineering and leadership topics every other week. It's called The Next Iteration. But if you sign up through that link, you will get access to that book, 10 More Days to Become a Better Developer, which has a bunch of these exercises. In fact, it's specifically focused on the factory and the strategy as being key examples, as well as, in this case, 8 other exercises. These are designed to be about 15 to 30-minute exercises that can work into your busy schedule, right? Nobody wants to spend 3 hours doing learning, but you can afford 15 minutes. This will take you an iteration to complete, and you will have a better idea of software design practices and have put them into real use. So, next piece of that is, would you all help me get better? I've given this talk a couple of times, but I find each time's a little different. Sometimes because of the questions I get, sometimes because I realize, wait, I've got to tell you about this neat way. That's a little bit more happened this time. I would appreciate having your feedback on this talk. Tell me what went well, tell me what didn't go so well, what you would have loved to see more of, all of that. And of course, if you share me your email, I will add you to the newsletter if you'd like. And if you don't like it, just unsubscribe, no problems. But I'll be coming out with a blog post today. Today is Monday, so it'll be tomorrow. May get you in that. If not, it'll come out on Friday when I resend it to the new subscribers. Today, I am planning on posting a blog post on what I learned about writing readable code from reading old books. Specifically, I was listening through and reading through my favorite translation of the Book of Five Rings by Musashi. And the translator did me a favor. And the lesson I learned from that is what the blog post is tomorrow.
You got it.
I figured you would like that.
You got it.
Alright.
Great.
Are you pleased with what you bought, sir?
Oh, yes, thank you very much. Thank you very much. It was a great. Thank you. Thank you for visiting us. And if you have more things to ask, Daniel, please ask. Or if you want to ask me, or if you wanted to make the next presentation.
Be warned.
Yeah. Yes. What do you think,
Matt.
Matt?
We were ripping him earlier. He was planning on coming and I wanted to
we
contact.
talk about
We'll see.
presentation.
I'm not against it.
Yes, and if you want, or if you want, if you want to hear topics here that, well, topics that you want to hear something. We talk a lot about AI in the last 2 years, I think, less than 2 years. And it was always questioned, are you afraid of AI? Have you seen the documentaries? Terminator 1,